Welcome to Philsci Hub Research University, your ultimate guide on your next research project.
We will lay down the best practices in research ideation, literature review, experimental design, and data analysis to guide you as you carry out your research project. Learn from the Philsci Hub team of research scientists and some invited subject matter experts. Philsci Hub Research University will be your personal coach through every stage of your research project, from ideation to final assessment.
And the best part, it's absolutely free.
Visit us at philscihub.com and be part of this learning journey.
Let's learn and succeed together here at Philsci Hub Research University.
Mabuhay! Welcome to the Filipino Science Hub. Thank you for your continued support to this online platform. To our new participants, thank you for checking us out today, and we would like to officially welcome you to the Philsci Hub family. Before we start the webinar, I would like to share some house rules in order to facilitate a smooth session. For our Zoom participants, we would appreciate it if you could turn your audio and video cameras off during the webinar. If you have questions or comments, feel free to type them on our Zoom chat box or YouTube live comments, and we will try to accommodate as much questions as possible. After the talk, we will have a 30-minute Q&A where the Zoom participants will have the opportunity to ask their questions live. For those who would like to receive a certificate of participation, a Google form link will be posted on our Zoom chat box, YouTube live comments, and YouTube video description towards the end of the webinar. Again, welcome to all our Zoom participants and YouTube live viewers. For those who are new and may not be familiar with who we are and what we do, allow me to share our mission and vision in the next few minutes. Filipino Science Hub is an online platform founded by our CEO, Filipino scientist, Dr. Jeffrey Camacho Bungkin, back in 2012. Currently, we are a registered nonprofit organization based in Houston, Texas, United States. Our mission is to promote STEM education and the culture of research among students and teachers in the Philippines and abroad. Our current global leadership team is comprised of volunteer Filipino scientists, seasoned STEM educators, and business executives across the globe. Our vision is to see a technology and innovation-driven Philippines, and we believe that this can be achieved by creating a new generation of well-rounded Filipino STEM enthusiasts. The vision is being carried out via our two major programs, the Philsci Hub Ed program and the Philsci Hub Research University. Through Philsci Hub Ed, we are able to empower and support our teachers by strengthening STEM fundamentals education. We believe that this is important because the more equipped our STEM educators are, the more they can inspire students to pursue a career in science, technology, engineering, and mathematics. The other major program that drives our vision forward is Philsci Hub Research University. This is where we provide tools for fundamentals of research and bring practicing scientists closer to the educational sector. Our official website is www.philscihub.com. This is where you can access all our materials such as webinars, tutorials, modules, virtual lab, and features, all of which are free. We are also present in several social media platforms, so follow us wherever you are most active on to get updated with our web events. Again, thank you for being with us this morning. To officially start our webinar, I would like to turn the virtual floor over to our host today.
Hello, good morning everyone. I'm Jessica Herrera from UP Los Banos. Welcome po and thank you for joining us here in day 2 of our lecture series, Mekus Mekus, a review of these mastered concepts in high school physics. I hope maging fruitful po ang ating discussions today. Marami tayo makuhang insights and ideas from our guest speakers. So may request lang po ang ating guest speaker for a quick survey. Maybe if you can type using our chat box, the cities or provinces we are from. Pag-type lang po sa ating chat box para meron po tayong quick survey kung saan tayo galing, kung tayo, nasaan po tayo ngayon. Yan, from Cabanatuan City. Pa-type lang po for everyone. Thank you very much. Ayan. So, iba't ibang sulok ng Pilipinas. Maraming salamat po. Ayan, keep on typing lang po kung saan tayo naroroon. Ayan. Okay. So, meron taga Davao, Las Piñas, QC, Batangas, Tacloban City. Welcome po at maraming salamat po. Okay. Keep on typing lang po at sinasurvey po ng ating speaker kung saan tayo nagmula. Okay, maraming salamat po. Now, without further ado, I will introduce our first speaker. Our first speaker is a respected figure in the world of physics education research. Her dedication to improving teaching methods through assessment and evaluation, flipped classroom techniques, and quality assurance was unmatched. Known as a loving mother and teacher, she played multiple roles in the lives of her students as a guide, a friend, and a mentor. Her unwavering commitment to her students and her passion for her work made her an inspirational figure in the academic community. Ladies and gentlemen, I would like to present to you from UPLD, Associate Professor Rosemary D. Bichetto. Hi, Ma'am Rose.
Hi, hello everybody. Thank you very much, Jessica, for the very kind introduction. It's so exciting to be with you. It's unimaginable that we have connections with all the teachers, with all the students from all over the country. That's so exciting. That's so cool. You know what? Maybe you can use the chat box to greet everybody in your own language or dialect, if they call it dialect or language. Pakibati naman kasi kami dito sa Laguna. Syempre, magandang araw, magandang umaga, magandang buhay. Kayo kaya, baka pwede nating batiin ang isa't isa sa ating sariling nating mga lengguwahe, no? Ilan ba ang lengguwahe ng Pilipinas? Mahigit 100, di ba? I hope that I can use both English and Filipino. Is that all right? I can use both Tagalog and English in my talk. Ilocano, bas it lang. Bas it lang. So, di na lang. Just English and Filipino. Do we have overseas? Do we have overseas or we're all Filipinos here? Ma'am Cheska, can you answer that? Are we all Filipinos here? Maybe we also need to greet international visitors or parts of the audience? Wala naman.
Puro Filipino naman po.
Okay. Pero salamat talaga sa ating sponsor, no? Ang ating sponsor, the Filipino Science Hub na based sa America, sa US. Tapos syempre ang IMSP, no, especially the physics division, napakalaking bagay ito na nagre-reach out tayo sa lahat ng ating mga kaguruan, no? Ng ating mga noble heroes, frontline heroes, pandemic or not. And of course, our math and science students. Pwede rin ba na makita yung ating, ano ba ang ating grade level? Meron na ba? At sa anong grade level kayo sa mga estudyante? Sa mga teachers naman, ano yung mga major subjects? Meron na ba tayong ganong data? Maybe para lang we can connect with each other. Yan. At very good, may grade 12 tayo. O batay sa ating survey, no? My dear audience, isa sa mga tips, no? Isa sa mga tips talaga, not even in teaching, no, just in speaking with one another, getting to know each other, is to be able to connect with the audience. Sino ba ang kausap ni Ma'am Rose? So sino ba? Ako na-introduce na eh. I'm a faculty of proud to be with you. So happy actually. Sabi ko nga, I am more excited to join you than the organizers. And I'd also like to greet our director. Sorry, the director of the IMSP. I saw her name, Ma'am Edith. Thank you for joining us. Kasama rin ba natin yung ating physics head, Dr. Ivy? So anyway, thank you very much. And we have the poll. I don't know if everybody can see the poll, but very good to know that we have college students in our midst. Wow. And then grade 12, grade 11. Wow, di ba anong grade ba yung nag-iisip na kung ano yung kanilang gustong kunin sa kolehiyo? Grade 11 siguro, tama ba? Kasi grade 12 ay more or less na dapat nag-a-apply na kayo kung saan kayo mag-aaral, no? Yan. This is really getting to know each other. So we have students interested in physics. Wow. Yes. 45%. Very much interested. Tama ba yon? Very much interested. That's good. Meron one or two. But I hope you'll change your mind at the end of this webinar. And for teachers, we have science education. A very relevant field, because without teachers, there can be no scientist. Diba? Our scientists would have to start with teaching with teachers in grade school and high school. Thank you very much. So we have teachers in mathematics, biology, physics, and science education. But in science education, is that broader, or is that a master degree? No, maybe graduate degree, and others. Very good. Thank you. So I will set that aside, and I would like to thank the organizers, because ang bilis nila, no? Sinabi ko, I want to know the audience. Ang bilis, no? Poll kaagad. Very good. Allow me now to have a very special sharing with you. Disclaimer, I'm not going to talk about misconceptions. I'm not going to talk about concepts per se. But I'm going to talk about a degree program, maybe that's not too well known, offered by UPLB, offered by the College of Arts and Sciences, and that involves the Institute of Mathematical Sciences and Physics, Institute of Chemistry, Institute of Biological Sciences, and the UP Rural High School. So we are very, very blessed to have 3 national centers of excellence as our base for the teaching of many of our courses. And meron pa, we have the College of Public Affairs for the education stream or education courses. So without further ado, ano ba itong pinag-uusapan ni Ma'am Rose? Oops, I have to find it. Nasaan na ba yun? Oh, I can't find it. Nasaan na ba yun? Wait lang. I'm sorry. Ba't hindi ko makita? Bakit nawala? Wait lang. Sandali lang, class. Sandali lang po. I'm not sure why. Here it is. Can you see po? Can you tell me what you see? On the chat box? Very good. Thank you very much. So I understand that this webinar is entitled Mekus Mekus, whatever that means, So ang nangyari tuloy, I had to look it up. So ako yung Mekus Mekus, and then Cheska and Ma'am Rhea, they were very excited to tell me that it's mix in Indian ba yon term na halo-halo, ganyan. Sabi ko, halo-halo, favorite ko yon. So nung sinabing Mekus Mekus, ay ang naisip ko ay halo-halo. And halo-halo kasi is my favorite snack. Pwede na ring meal. Halo-halo, it has everything. Yummy, yummy. On the chat box, everybody, para kayo ay excited. Sino ang gusto din ng halo-halo? Pakisabi nga. Sino yung Type, bet ko, halo-halo. Slay. Pakisabi nga, bet ko, halo-halo. At ano ang gusto ninyo sa halo-halo? Kaya, tara na po sa UPLB. May halo-halo ba doon? O ganda-ganda ng UPLB. Diba? This is our CAS building. And now known as the Dean Edelwina Legaspi Hall. No, she's the first dean nagtatag ng CAS. And of course, our monument, the oblation. And tara na po at maghalo-halo sa UPLB. May masarap pong halo-halo dito. Yan. At sa halo-halo, syempre, may maraming mga sangkap, di ba? On the chat box, everybody, ano ang paborito nyo? Pinaka-paborito nyong sangkap sa halo-halo? What do you like to eat first? Sige nga. Wow! Nata, leche flan. Okay, ano pa? Sago, slay, ice. Oo nga naman. Walang halo-halo kung walang ice. Ube, tubig. Tubig talaga, hindi ba gatas? Yan. Makapuno. Baka depende kung saan kayo, anong klaseng halo-halo meron sa probinsya nyo. Diba, no? Okay, so, marami. Siguro makaka-relate sa akin na leche flan. Diba? Yung nasa ibabaw. Ano muna tayo, tumitiki muna tayo ng leche flan. Minsan kinakain na natin before we go to our halo-halo. And ano yung leche flan para sa akin? Yung sinasabi ko sa inyo, ang BS, Mathematics and Science Teaching. So my talk is about promoting a very unique program, BS, Mathematics and Science Teaching only in the UPLB. Wala pa akong alam na offer niyan sa buong mundo kundi sa BS, kundi sa UPLB. And since ano pa to, established 2002, but it was first offered 2003. Okay? Ngayon, kung naalala nyo pa, yung World Teachers Day theme ng if I'm not mistaken 2020 or 2022, that teachers lead in crisis and that teachers reimagine the future. So adopting that theme, I said, let's claim that the BSMST is actually a leader, no, in addressing a crisis. And what crisis is that? And a leader in reimagining the future. Okay. So anong crisis ba yan? Eh di syempre, walang iba kundi ang educational crisis natin. Tingnan nyo naman. According to the Philippine Education, according to PBED, the Philippine Business for Education, no, na sa kanilang report card, State of Education Press Conference dated 2021. So bagong-bago lang yan. Ang daming mga sobrang alarming na data. But let's focus on high school. No, mostly high school teachers here, right? Tama ba? Junior high school teachers and also students. Look at the right side, no, the table on the right side, 72% are low achievers. Anong ang ibig sabihin yan? No, napakataas ng porsyento ng ating mga kabataan. 15 years old ang kasama sa survey na ito. Sa PISA, yung International Assessment Instrument, na nagpapakita na 1% lang daw ang proficient sa math. So that means 1 out of 100 students. Tapos tignan mo sa science, only 1 out of 100 ang proficient. At ang masakla pa dito, itong mga junior high school students natin, kahit na mababa ang kaalaman o konti lang ang kaalaman sa math at sa agham, ay nag-move up. Move up saan? E di sa senior high school, di ba? Tingnan naman natin po ang ating mga kaguruan. Okay, medyo malungkot din po dahil sa pag-aaral ng PBED, no, dito sa isang questionnaire o isang test, pagsusulit na ibinigay nila sa mga guro sa English, Math, Filipino, and Science noong 2014, lumalabas po na mababa ang kaalaman ng ating mga guro sa iba't ibang mga asignatura. Tingnan po natin ang siyensya. No? Look at the grade school level sa grade school teachers no natin ay mga 10% lang ba ang nakuhang score o percentage of questions answered correctly. So ito na yung score nila. So can you imagine a score of 10%? And in science, grade 10 high schools 30%. Yung median na po ito, no? Median. O medyo mataas sa math, pero very alarming. Tama ba? Look, sa English mukhang mataas, pero math and science, no? Really very, very concerning. Kaya parang nakakalungkot naman. Pero huwag tayong mawalan ng pag-asa. Never tayo mawawalan. Kasi, no, oops, nasan ba? Parang bumaliktad tayo. Yan. Kasi po, ang magandang balita ay, no, sa ating magandang balita ay meron tayong BSMST na handog. Wait lang, parang nabaliktad kasi. Okay, eto po. Ang alay ng UPLB sa mundo ay ang BSMST. O alam ko naman na ang ang attention span ng nating lahat no ay medyo maikli. So mas maganda po siguro kung tayo ay pupunta sa isang video. Panoorin po natin ang isang video. Nako.
Magandang araw sa inyong lahat. Ako si Mariel.
At ako naman si Tim.
At narito kami para sa panibagong episode na naman ng IMSP
Moments Seized for Teaching.
Sa araw na ito ay tatalakayin natin ang kursong BS Mathematics and Science Teaching na iniaalok lamang sa University of the Philippines, Los Banos. Tim, matanong kita, bakit tayo magkasama ngayon sa kursong ito? Bakit ka nag-BS MST?
Alam mo Mariel, bata pa lang, pangarap ko nang maging guro. Whenever I see my teachers discussing a lesson, I always imagine myself being them. Sabi ko sa sarili ko, gusto kong gawin ang ginagawa nila. Pagturo, which I later realized, ay higit pa pala sa inaakala ko. Indeed, it was a noble profession. So when the opportunity knocked, I welcomed it with open arms. I chose BSMST as my degree program.
Wow, that's quite a summary. Pero relate ako kasi ganyan din ang pakiramdam ko noon. BSMST has 4 areas of specialization. Ito yung tinatawag na major natin kung saan tayo pipili from biology, chemistry, physics, and mathematics. Bakit? Dahil ang degree program na ito ay joint program ng 3 units ng College of Arts and Sciences. Ang Institute of Biological Sciences, Institute of Chemistry, at Institute of Mathematical Sciences and Physics.
Alam mo ba Mariel, 2003 pa when BSMST was first offered in UPLB as a 4-year degree program during the term of UP President Francisco Nemenzo Jr. Ipinanukala ito ng College of Arts and Sciences in cooperation with the College of Public Affairs na humahawak sa mga education courses ng BSMST. Ito ay sa ilalim ng liderato ni Professor Rolando G. Panopio na siyang founder ng BSMST at naglingkod bilang kauna-unahang program coordinator of MSTP. After undergoing revisions in its curriculum in 2011 and 2018 to fit the spiral approach of the K-12 curricula, BSMST continues to prosper and has produced highly qualified teachers in high school mathematics and science over the years.
Uy, totoo yan, Tim. In fact, pinagmamalaki ng BSMST ang graduates nito na consistent ang mataas na performance sa licensure examination for teachers through the years. Proud kami dahil isa na namang BSMST ang namayagpag. Isang bagong guro ng bayan at led top 10 na si Eliza Bautista ng batch 2017. Honor and excellence. Yan ang tatak ng UP. Tim, i-share natin ang mga patotoong ito mula sa ating very own BSMST kapamilya.
Hi, I'm Kuya ING and I'm a BS Mathematics and Science teaching shift. So I'm from BA Communication Arts. Nag-shift ako nung second year college ako. Now, currently, I am a biology major and super nag-enjoy ako sapagkat napakaraming bagay ang pwede mo matutunan dito sa BSMSP. Whether it is into teaching, biology, mathematics, science, physics, napakaraming matututunan. So, ika nga ay 4-in-1 kami, dinaig pa ang kape. Kaya naman, hindi ko pinagsisihan yung naging decision ko na mag-shift dito sa kursong ito. Try nyo itong MSP sapagkat napakagandang degree program ito para sa inyo at para sa ating mga.
Good day, everyone. My name is Dominic Jan C. Albolo, and I'm here to share with you how my pre-med course, BS Mathematics and Science Teaching, helped me. First, I would just like to share with you that my major is actually physics, and actually prepared me to the work that I would soon be doing later on as a missionary teacher on the mountains of Mindoro. So I was blessed with the opportunity to actually go there and be one of those teachers and be able to help them go to college and help them graduate. And I also would just like to share with you that my experience there helped me, by the grace of God, to also pursue medicine. For those of you who don't know, for you to be able to be accepted in any medical school, you need to pass the National Medical Admission Test. And guess what? There are 8 subtests in that test, and 4 of which are biology, mathematics, chemistry, and physics. So if you are dreaming to become a doctor, I think the BS Mathematics and Science teaching degree can actually help prepare you. God bless, and I hope that this was able to help you and encourage you to take the BSMST course. The BSMST program goes beyond its promise of making sure that MST graduates are content-ready innovators, competent in biology, physics, chemistry, and mathematics. Leaders who listens and are built to be responsive to the needs of our changing educational landscape and shapeshifts to the needs of our all unique learners. Honor always precedes excellence. That excellence without honor is meaningless. Sa UP, ipaparamdam sa iyo na ang sukatan ng pagka-Pilipino ay kung ikaw ba ay nakakapagbigay ng ambag sa kabutihan ng bansa mo. This consciousness of honor and excellence in both my mind and heart paved way to what kind of person and leader I want my teachers and my students to emulate in their lives.
Wow! Mapapauna lang ako sa mga thoughts nila.
Tatak MSP yan. Ito ang ipinagmamalaki naming tahanan sa kaiga-igayang campus ng UP Los Banos sa Laguna. Laging bukas ang aming tahanan para sa inyo.
Hayaan niyong samahan namin kayo, ang pamilya ng BSMST sa inyong paglalakbay sa pag-abot ng inyong pangarap na maging instrumento ng pagyabong ng kaalaman sa kabataang Pilipino.
Wanna be MST? Let's go!
Ito ang MST Moments Seized for Teaching. Pagayang mga susunod na scholar ng bayan.
Okay, ano kaya nararamdaman on the chat box? How do you feel about BSMST? And how do you feel about going to UPLB? Diba? Sige nga, how do you feel about it? Sino diba ang gusto magturo? Who considers teaching a very noble profession? Tuloy po natin. Can you hear me? Can you hear me po? On the chat box, meron bang mga sharing ng nararamdaman? Ano pong na-feel nyo dun sa video? At go ahead lang po, kung na-excite ba kayo? Meron pala na isang kurso sa kolehiyo na hindi lang isa ang major. Actually, kaya mong ituro kahit na alin doon, math, physics, chemistry, or biology. Pero meron ka pa rin, syempre, isang area of specialization. So, handog namin sa Inang Bayan na handog ng UPLB ang BS-MST. At inaanyayahan ko rin po kayo na tignan ang ating, i-type nyo lang po, i-google nyo lang po ang BS Math and Science Teaching. Meron po tayong isang website, bagong website, which talks about the curriculum, pati mga faculty, pati yung vision mission natin, ganyan, at ilang mga balita tungkol sa BSMST. Ngayon naman po, meron pa po tayong isang video. This time, pwedeng wait lang. Paano ba i-pause? Yan. Gusto ko lang po sabihin na bakit may isa pang video. Ito naman, para lang ipakita sa inyo na hindi lamang pagtuturo ang ginagawa sa BSMST, kundi mahalaga ang research. No? So meron din kami mga ginagawa sa research na kapakipakinabang sa mga paaralan o sa mga mataas na paaralan na goal namin na actually to reach out to everyone, just like the PhilSci Hub. So watch this po, and it focuses more on what we are doing in research. Pero actually, tapos na po itong project na to, and we're doing other projects just as exciting as these are.
After sunrise, UPLB is not only known for its beautiful campus, it is a renowned research university in many fields of basic and applied research. UPLB, home to the Bachelor of Science in Mathematics and Science teaching program, not only produces highly competent math and science educators, MST students are also being trained to conduct action research to upgrade the quality of basic mathematics and science education to benefit local communities. The school year 2021 to 2022 is an exciting time for many BSMST students and faculty members. There are 8 collaborative research teams for each grade level in both mathematics and science. These teams thoroughly review and evaluate mathematics and science assessment tasks and develop supplementary multimedia learning materials for online setup. This research project is in collaboration with the Los Banos National High School and is funded by the Los Banos Science Community Foundation Incorporated. For nearly 4 decades, the foundation helped the transfer and adoption of S&T research and services to clients and various projects. This research project is being supervised by the Education Sector Committee, headed by the MST Program Coordinator, Rose Eusebio. There are an amazing 23 educational research studies. 21 are ongoing as I speak. 2 research studies have been completed. One study is ELPAS, the coolest grade 10 mathematics interactive learning module about patterns, conceptualized by Christian Carlo Garcia, a fresh graduate of BSMST.
Hi, I'm Christian, the creator of Alphas, which is an interactive learning module on sequences and series. And the idea about it is to make the learning experience of grade 10 students be more fun by adding game elements and storyline to it.
Graduating MST Biology major, Oliver Ezekiel De Jesus has the most creative way of studying evolution in grade 10 science.
Good day, I'm Oliver, and students taking up the modular mode of learning are in need of extra support. That is why I have conceptualized, designed, and developed a card game-based learning material for the topic evolution for grade 10 students.
Soon to join the grade 12 science education research team is graduating MST Physics major, Paulo Tamandong. Sir Paulo developed 5 learning modules in grade 12 general physics, both for the modular distance learning and online learning modalities.
Hi everyone, my name is Paulo Tamandong, BSMST Physics major. My SP, I created 5 learning modules for the senior high school physics level. So during the pandemic, may challenge na nag-arise para sa mga teachers na magturo ng subjects nila through distance learning. So if you have a drive and a dream na makatulong sa education sa mga kababayan yung Pilipino, I encourage you to join the BSMSD program.
Through the supervision of the UP Open University, the developed teaching and learning materials will be shared online to the Los Banos community. Pandemic or not, the UPLB, LBNHS, LBS CFI collaborative research teams is one with you in ensuring that quality education is made available to our students. This is our commitment to excellence. This is our pride.
Wow. And we move along. Ito naman po yung Facebook. If you're on Facebook, pwede naman pong tingnan nyo. Silipin nyo po, bisitahin ang UPLB BS Math and Science Teaching na official Facebook page. Thank you very much. At so, tingnan pa natin. So ano po yung mga iba pang sangkap? Pero bago natin puntahan yung ibang sangkap, di ba dalawa pa lang, leche flan at saka ube, no? Ay yung bisitahin natin, ano ba ang pinaka-goal? Ano ba ang gustong maatim o ma-attain, no? Ma-attain ng ating BSMSC program. Eh di syempre, be competent teachers in content and teaching skills, hindi lang sa math, kundi sa basic sciences. Pagkatapos, syempre, effective use of pedagogies and didactics. So, hindi lang content, kundi delivery ng content. Tapos, syempre, magiging makabayan, no? We want to help in the crisis to address the educational crisis that we are facing of low-performing students. So, sumasali dyan ang BSMST at mga graduates ng BSMST. At katulad ng sinabi kanina sa video ni Sir Ivan, no? Aanhin mo ang excellence kung wala ka namang honor. Diba? Kaya importante yung meron tayong emphasis on educational values. Kagaya po nung oblation na ito na kung saan yung ating mga values ng critical thinking, integrity, honor, open-mindedness, compassion, no, service. In fact, itong ating ginagawang webinar ngayon is because of reaching out to the Philippines, different parts of the Philippines, as an act of service to all of to one another, and we continue, no, to serve the Filipino youth as role models, and then also for yung maging kapaki-pakinabang tayong mga mamamayan ng hindi lang ating bansa kundi ng ating mundo. Kaya ito po para dun sa mga dadalaw sa UPLB o hindi pa nakakadalaw, dito po ang building ng Institute of Mathematical Sciences and Physics, pero meron na rin po kaming bagong building ngayon for mathematics, at saka this building also houses the Institute of Chemistry. And dito naman ang IBS. Kung mga biology courses naman, dito naman kukunin. Kanina yung sa Math and Chem. At of course, para sa ating practice teaching, practicum of field studies, dito naman sa UP Rural High School, no? At alam nyo ba, no, chika, ang ating bagong-bagong high school principal ng UP Rural High ay isang BS, MST, no, graduate physics major, no? Napaka-versatile niya kasi yung master's naman niya ay sa math. So, very versatile po ang BSMST nating mga graduates at high caliber. O di, eto na tayo, sago at gulaman naman. Bisitahin natin ang mga top-notchers sa LET. So, naalala nyo, di ba? Kailangan bago makapagturo, lalo na sa public high schools, ay kailangan ipasa ang licensure examinations for teachers. At napakagandang balita po Kasi unang-una sa lahat, o tingnan nyo naman, no? Laging top performing school. Top performing school, pag more than 50 and above ang mga examinees mo, magiging top performing school ka. Pero kung less than 50, pero hindi ka maka-count as a top performing school. Pero hindi mababawasan, no, ang hindi matatawaran po na lagi-lagi pong 100% passing rate, no. Ang medyo sumablay lang ay 4 na taon na 98, ibig sabihin nun may isa. Pero primarily po, lagi pong perfect, no? Laging 100% passing rate. At gusto lang namin i-share, bigyan ng papugay, ang ating mga top notchers sa LET. Si Angel ay ngayon ay nag-masters na sa Ateneo for math education. Noviel is he's in chemistry. At ang alam ko ay nagtuturo din siya sa Ateneo High School, no? At ito naman si Eliza Bautista, homegrown talent ng Los Banos. Dito po siya nagtuturo sa isang high school dito. At ang latest po ay si Nicolo Alexio Rodriguez Frando na nitong 2022 na top 6 at kaya kinuha nga siya ng reviewer, yung nagre-review na center na maging reviewer po sa kanilang review center. Yan. At yan, ano pa po. Okay, maybe we can all read this together. I don't know if there's audio or say it together. 3, 2, 1. One child, one teacher, one pen, and one book can change the world. Ikaw ba yon? Ikaw ba yung child na yon? Are you that teacher? Is it your pen? Do you have one book? If the answer is yes, you and I can actually change the world. According to Malala Yousafzai, nakilala niyo siya na bilang Nobel Prize, Nobel Peace Prize winner and her advocacy for education for women. At ito po, padayon? Ano nga bang ibig sabihin ng padayon? Padayon, sige nga on the chat box. Padayon, pang mga panghinaharap na guro ng bayan para sa bayan. Kayo yon kapag kayo ay sumali, no, sa BS-MST. Tara na po sa UPLB at sumali kayo sa BS-MST program. At mabubuo na po yung ating halo-halo na favorite po. Okay? Allow me to stop share. Now, can I have just a few minutes po? Let me just show you. Kasi di ba para makita nyo naman po, yung, let's see. This one, wait lang. This is an example of Physics 50 e-portfolio. I teach Physics 50, and in lieu of a final exam, what I opt for is an e-portfolio because the e-portfolio is very comprehensive. It's an authentic form of assessment. Lahat na po ng kanilang ginawa doon ay nakasummarize. For instance, ito ay kay Nico, Ambrosio, and I'm sure that he'll be proud that I'm sharing this with you. Ang kanyang theme ay exploration. May reminder siya na ito ay isang tour. So if you click this, may music siya. And I think this is an original composition niya. So very talented ang mga BSMSC students. Ito yung e-journal ng every destination. Ang ginawa kasi namin sa Physics 50, kunyari, you're on a ship of imagination called the SS Wanderlust, the Spaceship Wanderlust. So we're traveling through space and time habang na kami ay nag-explore ng physics historically, and philosophically. So yun sa spaceship, they have a journal entry for every destination. They have a notebook, they have reflection, and they have this is a podcast on what an ancient Chinese cosmology na ginawa nila. I don't have all the time, but I'd like to just give credit for Nicolo. Siguro pakita ko lang yung just an example of what his creativity, no? Ng what he does, like kunyari sa e-journal niya, merong ito, mga destinations, getting to know you, physics as a science, making sense of the physical world, the stars and the planets, measuring matter, motion and interaction, energy, magnetism, electricity and light, ito po, and modern physics. So, yun yung mga destinations. Hindi na tayo papasok dun sa mga ibang mga entries niya. Now, allow me to share this one. Ito lang, just ito po, ginawa naman to ni Leslie. Klase naman siya ni Nicolay. Dito tayo, dako tayo dito sa bandang, just to show you po, just a sneak preview niyan. Okay. Yan. Si Liz naman.
Because we're going to present your universe.
Sample lang po yan, patikim lang po yan. And then let me end with a very exciting, so nakita nyo po, the pandemic did not, well, yes, it made a dent. It made us sad, frustrated, but it challenged us to really do better. So we did flip classroom. So ngayon, ginagamit pa rin yung mga learning management systems na yan. No? And we do the activities live, face-to-face na. Pero nung pandemic, we had videos like that. So hindi pa rin nawala yung hands-on spirit. Okay, and the creativity is there. And then I'd like to share with you an output of a course that I taught before the pandemic. Ang pangalan ng course ay Physics in Everyday Life. So it's a GE course, no? Ang ginawa namin, it's very non-traditional. Kunyari, mechanics is all about amusement parks. We don't say mechanics, we say physics of the amusement park. At yung output nila ay to go to have a musical video. And ang field trip namin ay walang iba kundi sa Enchanted Kingdom ng Santa Rosa, Laguna. So I'd like to share with you very short 4-minute output po nung isang estudyante, and this time it's all about momentum.
Hi, Ma'am Rose. Can we share this na lang po through a link? Yung video? Ma'am Rose? Wala.
Together we're going.
Ma'am Rose.
Forces gain while we are moving. We each other side by side. Unstoppable.
Ma'am Rose. Sorry po. Wala.
Oh. And when something falls, from the damage as we resist the rain. No distractions. You're moving towards my direction. Ride with me this time. I'll take this final never fade away. Don't let down. Speak.
Ma'am Rose, can we stop the video na lang po and share it some other time? Sorry po to interrupt. Wait lang. Hi, Ma'am Rose. Sorry po to interrupt.
Okay,
But
sorry
we
po.
have no time po to post the video
I'm
and
sorry,
we're having
I might have
technical
to
problems din po.
Sorry.
Okay, ma'am. Sorry to cut you off po.
Okay, pa-off na lang. I'm sorry. Okay,
Yes, ma'am.
actually, I'm finished na po. Finished na po. Sorry. Oo. Thank you po for the time. I'm very grateful po. I'm very grateful for this time. And sige po, I congratulate everyone again for giving me this opportunity. Okay. Sige po. Hope everybody nice day and have a nice time with Dr. Kwansing.
Yes, thank you very much po, ma'am. Sorry po, we have a
Bye.
very short time.
Yes,
Very
sorry
short time.
then. Thank you.
Thank you very much. Thank you very much po, Ma'am Rose, for sharing your time. And it was a very informative introduction to a new course, MSP po. So I think the audience are very interested to enroll some of our students to enroll this program. And Ma'am Rose will answer the question in the chat box po regarding the modules that you've shared for
Oh, really? They're
physics.
interested.
Yes, they are
Sige, ma'am.
interested for that po.
Siguro,
So I
ma'am, they can email me na lang po. They'll
sige
email
po,
me na
sige
lang.
po.
Pa-share na lang po ng email ko sa kanila.
Okay po, sige po.
Thank you very much.
Thank you, Ma'am
Bye.
Rose.
Maria. Apologies po for taking too much time.
Malilate na po kayo sa
Oo nga,
appointment.
sorry po. Okay.
Pero salamat po, Ma'am Rose. So at this point,
Maria.
I will introduce to you our resource speaker. So he earned his BS Physics degree from UP Diliman and his PhD abroad at Purdue University. He also did postdoctoral studies at the University of Pittsburgh and National University of Singapore, and also a diploma student at the International Center for Theoretical Physics, or ICTP, in Italy. He was previously the president of the Samahang Fisika ng Pilipinas, where he promoted and emphasized the need for continuous upgrading of physics education. So currently, he is the vice chair of the physics division of the National Research Council of the Philippines and a member of the General Council of the Asia Pacific for Theoretical Physics in South Korea. So he is also a professor here in IMSP, University of the Philippines, Los Banos, and doing his research, which is focused on quantum transport, quantum thermodynamics, and other theoretical condensed matter. So without further ado, let's all welcome Dr. Eduardo Siquansi Jr. So sir, you may take away the screen.
Okay, hello. Yeah, so thank you, Dr. Mero, for that nice introduction. Good morning. Good morning, everyone. Can you hear me? Can you hear me?
Yes po, very clear po.
Right, so good morning. Maayong aga sa tanan. Okay, I'm from Bacolod, so I speak Hiligaynon as well. How much time do I have?
You can take until 12 po, it's okay. But we can give time for question and answer po.
Okay, sige. Right, so I promise to end before 12. Okay. Right. So let me see. Can I share? All right. This morning, I would like to give, instead of a presentation with a slide, I would like to give a lecture. Okay, where as teachers and as students in high school, I would like to give you an experience on how lectures are done, online lectures are done here in UPLB. So this is going to be interactive. That means if you have questions, something that's not clear, you can ask me anytime, okay? And then I can explain that here on the whiteboard that we have. So let's start off with the basics first. Okay, so just to set the stage, let me define what is physics. Okay, so you've heard physics lectures before. Okay, the past few last week you had a lecture on classical mechanics. Okay, but let me set the stage first before I discuss the topic at hand. Okay, so to me, physics is a systematic study. It must be systematic. Okay, so it's a systematic study of what? Of matter, energy, and their interactions. Okay, so matter, energy, and their interactions. An example would be, say, you have, say, the sun. Right, so let's say this is the sun, and then let's say you have the earth. So the sun, the earth, they are matter, and then they interact. Okay, let's say, for example, there's this force. Let's call that, say, ES, and then there's this force that's called, let's say, SE. Okay, where that force is the gravitational interaction. Ano bang gravitational interaction? You've seen this before, hopefully. It's GME MS over R squared, right? And then R hat. R squared is the distance between the two objects. Oh, by the way, I will have a few equations in this lecture, but it will be just algebraic, algebraic expressions. Okay? You don't have to do calculus at this point. Okay, so it's all algebraic expressions. You would also see that in physics, it's not all about the math. Okay, so that means you need to learn how to interpret the equations. So kailangan maintindihan nyo ano ibig sabihin ng equations. Okay, like for example, this one, the G here is a constant. This M and M. So this is the mass of the Earth. This is the mass of the Sun. And then R squared, where R is the distance between the Earth and the Sun. Now, this F is a vector. And what is this R hat? Okay, what does that mean? That R hat is a vector that points, let's say, for example, you look at ES. If that's ES, that R hat is a vector that points from the Earth to the Sun. Brown out? Brown out ba?
We can still hear you po.
Ma.
Sir, live pa rin po kayo, sir.
Brown out?
I can see you here.
Ba't nawala ng ano? Okay. So, can you see me? Can you still see me?
Yes po. We can also see your
Nawala
screen
yung kuryente. I don't know what's going on.
Your screen is still there.
Okay, so I'm still live. Okay, so that's good. Okay, so I can continue. Although nawala yung electric fan for some reason. Okay, baka na ano ng aso. Okay, anyway. Right, so R squared is a unit vector. It's called a unit vector. It's a vector that points from the Earth to the Sun if you're looking at FES. And then if you're looking at FSE, it's a unit vector from the Sun to the Earth. Okay, so what does that mean? That means this interaction is attractive. Okay, so that's attractive because the forces are pointed toward each other. Okay, so they would like, that means the Earth would like to go towards the Sun, and the Sun would also is being pulled towards the Earth. Okay. Another example of what we study in physics is, for example, you have a positive charge, okay, let's say plus Q, and then a negative charge minus Q. Okay, and then the force between them, I hope you've learned this in high school. The force between them is yung K. Okay, let's call this say Q1. This is Q2. Then that means this is KQ1, Q2 okay, over R squared. Okay, Q2 is minus, so there's going to be a minus sign here somewhere. Okay, so and then we have R squared. The thing here is that this is plus, this is minus. It's going to look like just like the Earth and the Sun, okay, yung forces between the two charges. And then R here is the same R, it's the distance between the two charges. Notice the similarity between gravity, okay, and electricity between charges. Okay, they look the same. Palitan mo yung G with K, and then the masses would be like charges. The R is the distance between them, and it's also a square. Okay, so that is one of the interesting things about the universe. R squared yung dependence ng distance for the forces, okay, either gravity or electricity. So that's an example of those are examples of what we study in physics. You can also look at, so ito ano, these are large objects, okay, and then large maybe say charges, okay. But you can also look at, say, for example, the light from the sun. Okay, the light from the sun are made up of photons. Okay, so photons, what are photons? Photons are particles of light. They carry energy and they carry that light. Okay? So for example, if from the sun, you're going to get photons from the sun. So let's say the sun is here. You're actually getting photons from the sun. So right now, for example, if there is sunlight in your location, you are actually receiving photons from the sun. Okay, and they are, as you know, they carry energy. So mainit, right? That's the photons. That's the energy that the photons are carrying from the sun. And let's say you have a solar panel dito. Okay, so if you have a solar panel, okay, so the photons would act on the solar panels. Okay, and then you get electricity from the solar panels. Okay, what actually happens is there are semiconductors in this solar panels. Okay, and then those photons would interact with the semiconductor. That means there are electrons in the semiconductors. The photons would act on those electrons, and the electrons will start moving, generating current. Okay, that is also an example of what we study in physics. Now, so in physics, maybe just a large overview of the topic itself. Okay, we study objects of different sizes, from the very small. Okay, very small, ibig sabihin, for example, molecules. Okay, we study the physics of molecules, and then we can go down to atoms, and then from there we can also go down to protons and electrons, and we can even go down to quarks. Okay, so the smallest object that we have right now that we know exists are quarks. These quarks are constituents of protons. And then we also have electrons. Electrons would be the carrier of charge in electricity, mostly electrons, okay? Hindi yung mga protons. And then yung quarks. These quarks are constituent of these protons. So we study the very small. We also study the very large. Let's see, how do we add this? Hindi umaalis yung Zoom. Let's see. We also study the very large. Okay, so let's say very large. That means just like what I said kanina, we can start with planets, say, okay, and then we can study stars, okay, the sun, and then we get to study, say, large objects like, say, black holes, okay, quasars, neutron stars, all those large objects with large masses, and then we can study galaxies, and then even the whole universe itself. Okay, so the physics of the whole universe, you can also study that, see how that would evolve in time, okay, from the Big Bang, let's say, up to the future, okay, which we still don't know what would happen. Is there going to be a big crunch, or will the universe keep on going? We still don't know at this point. And then we can also study in physics the in-between. So we start with the very small, yung mga electrons, yung mga quarks, and then the large one. And we can also study everyday objects, which to me are more interesting because these are objects that you see around you. Like, for example, with computers. Okay, what do we study with computers? Yung mga transistors. Okay, semiconductors. So physics, without physics, we weren't able to, the physics, the understanding that we got from semiconductors led to the invention of transistors. Okay, so without this understanding, we were not able to make a device that processes information. We can also study, say, superconductors, metals, insulators, and so on. Okay, even plastics, molecules, things like that. Okay, so in other words, physics. If you want to study physics, you can just study anything that you find around you. Okay, because there is physics in that. Okay, so physics of the small, physics of the large, and then physics of in between. Okay, so everything in between. Um, now, so physics, okay, so small, large, and in between. Now, physics can be loosely divided into, okay, loosely, okay, it's not going to be strict, divided into one, classical mechanics, the classical part, okay, the classical physics, okay, and then modern physics. Modern physics is my topic this morning. Okay, so I would like to discuss a little bit in modern physics, a concept that is important, it is crucial, but it's also the beginning of our understanding of modern physics. But what's the difference between classical and modern physics? In classical physics, what you learn, like for example, last Saturday, you learn about classical mechanics. These are the stuff that you learn, the very first things that you learn in a physics course, like for example, kinematics, Newton's laws, okay, di ba? Newton's first law, Newton's second law, may momentum, for example, okay, kinetic energy, all those things that you learn. Okay, so what is basic in classical physics is that if you have a particle, you know the mass and you know the velocity and you know the momentum. Okay, momentum is mass times velocity. What else do we learn in what do we study in classical physics? We also look at classical electrodynamics, like yung kanina, yung dalawang charges. So electrodynamics. These are charges, charges, magnets, okay, electric motors, antenna, Wi-Fi, things like that, okay? And then also, we can also include in classical physics, classical thermodynamics. Okay, naka-thermo, that includes, say, studies of refrigerators, heat engines, car engines, the transport of heat, okay, in everyday objects. So yan yung classical physics. What about modern physics? In modern physics, what we study is quantum mechanics. Okay, pagdating dito, now we see quantum. Okay, there's no quantum here in classical physics. Now we see quantum. That means we now go down to atoms, molecules, electrons, and we study them. We also look at statistical mechanics. I don't want to I'm going to talk about quantum mechanics in a little bit. Okay, so I can tell you a little bit about one of the assumptions in quantum mechanics. So modern physics, meron ding statistical mechanics, okay, which is the modern version of thermodynamics, but this time we use atoms and molecules to get how to understand how systems work. Okay, so how systems, the properties, and their dynamics would behave if you consider the atoms and molecules consisting that system, that material. And then we also look at relativity, special relativity, general relativity in modern physics. That means, say, high speeds. Okay. So we have classical physics and then modern physics. What is the difference between the two? Well, this one, okay, in classical physics, you have particles, you have objects with well-defined momentum and well-defined position. Okay. So let me draw that again. So classical physics, let's say you have a marble. Okay, let's say you have a marble. Right? Let's say it has mass m. And then let's say it's moving with some velocity v. Okay, velocity is a vector. That means it has magnitude and direction. Okay, let's say in direction is papunta doon, okay, and magnitude is some velocity. Okay, now let's put a coordinate system, right? Some x, y, z like that. Okay, and then let that be the position of the marble. Let's call that r. Okay, now yung momentum, which was also mentioned kanina with Ma'am Rose, yung momentum, let's call it momentum P, it's a vector, and that is mass times velocity. You just take the product of the mass and the velocity. Okay? Yung velocity na yan, okay, just multiply that by the mass of that marble. You get the momentum of the marble. Okay, that means if say your object, let's say that marble, has higher speeds, then it would have higher momentum. Or let's say you change that marble to a stone, or a large rock, then the mass goes up. Let's say the velocity stays the same, then the mass goes up, the velocity is the same as the marble, but it will have a larger momentum, right? So the dependence on the momentum is mass and velocity. In classical physics, we know exactly the position r and momentum of an object. Parang obvious, right? You have, let's say for example, merong sasakyan, merong say there's a car, right? That car say on the highway, okay, it has a velocity v, merong speedometer dun sa loob, right? You can look at the speed of the car, and you know the mass of the car, so you know exactly ano yung momentum ng car, right? And you know exactly nasaan siya. Like for example, meron kang coordinate system doon, you know exactly where that is, where the car is along the highway, and you know exactly what the momentum of that car is, right? That is the basic assumption. That is the basic assumption in classical mechanics. That's also what we find to be true, at least in this theory, sa classical physics. But we know exactly the position and the momentum of an object. In modern physics, that's not true. Okay, so in modern physics, we do not, we don't know exactly the simultaneous R and P of an object. Something's different, right? In classical physics, you know exactly yung momentum tsaka yung position, but in modern physics, we don't. Okay, so if let's say for example you have an electron, okay, gawa ka ng for example coordinate system like that, sabi dito, we don't know exactly where it is. Okay, ibig sabihin nun itong vector na yan, R, like that. We don't know exactly ano R na yan. And then we don't know exactly ano yung momentum yan, okay, which is mass times velocity. We don't know exactly this, and we don't know exactly this. Bakit ganon? That's what we would like to explore, okay, this morning. Okay. So let's do that. So let's explore why that's so. All right, so suppose you have a particle gun. Okay, so let's say you have a particle gun. Okay, how does a particle gun look like? Okay. Let's say, oops. Okay, let's say you have say, okay, you have a barrier, right? Then let's say merong circular hole, right? Okay, so that's a barrier. And then you have a particle gun, let's say big gun like that. Okay, so the shooting particles. Right. Okay, so we have a particle gun, Like you can imagine, for example, this is like a video game, okay, that you play, let's say Call of Duty or whatever you're playing. So may butas dyan, okay? So you have this large, parang machine gun, okay? But the machine gun is, yung mga particles are too small compared to the barrel of the gun, okay? So that means then parang shotgun, okay? That means these particles are everywhere, okay? But then there's this hole, okay? It's a circular hole, and then let's say you have a detector dito. Okay, let's say this is a detector. That means it's some thick metal, right, that stops the electrons. So the electrons, okay, when they go through this, okay, let's say tamang-tama pumasok dun sa butas in a circular hole, then it goes through, okay, and it goes through like that, okay. At some point, some of these electrons might hit the sides. Like that, for example, but hit the sides of the circular hole, and so that hole might change the direction of the particle slightly. Let's say pag ganun, okay, right? So it goes up like that. But here in the detector, what you would see is may butas yan, ano? Let's say directly in front of that. Okay, it's this. Okay, so you're going to see the particles hitting the detector like that. Right? Okay. Merong mga nasa boundaries. That's because of the interaction of the particles with the edge of the hole. Okay. So medyo pupunta dun sa dulo, so at the boundaries. But most of them are going to hit the inside the hole. Okay. So these are classical particles encountering a hole, and then you get to see in the detector something like that. Right. Now, suppose you change this circular hole to a slit. Okay, so let's say now you have a slit. Okay, so instead of a hole, you have a slit like this. Okay, yeah, right. So now you have this particle gun. So again, okay, going in, machine gun, particle gun. When it's that, okay. So again, let's put the detector here. Okay, what would we see? What do you think would we see? So particles would go through, they hit that, right? May ibang particles that will not go through that. Okay, pag dito tamaan yung metal dito, then it cannot go through. Only particles that can go through are those passing through the hole. So let's say yan, okay, passes through the hole, and what you would see is, let's say directly in front, okay, then you would see something like that, right? Does that make sense? Okay. The thing with classical physics is that it is close to our common sense. Yung perception natin of reality is actually classical. Right? So this looks like obvious, right? Parang obvious. Dumaan yung particles dun sa slit na yan, then that means what you see is something like that, right? Parang slit. Okay. So that's good. Okay, so we have classical particles passing through the slit. You get this pattern, okay, in this detector. Now suppose you place two slits. Okay, two slit barrier. May questions pala at this point? Everything is good? Okay, so it's close to what we perceive as reality. It is classical. Okay, wala pa yung modern physics dito. So again, this is our detector, and this is our two slits, and then again we have this particle gun dito, okay, shooting particles. Yeah. Now we have these two slits, and what happens? Well, of course, there are going to be more spaces. There are going to be these two slits where the particle can pass through, right? So it can pass through that way, and the particle can pass through that way. So nakalampas doon and doon. And then what you see is dalawang lines, right? Kasi may dalawang slits. Right? Again, obvious, right? Parang okay. So what's so interesting with that? Okay. The thing is, when you deal with now electrons, you're not going to get this. Hindi na obvious. Okay, pagdating sa electrons, you're not going to get this. May dalawang line ganun, right? Okay, that's what you would see. That's what we predict, and you can perform this experiment. For example, well, don't use a gun, right? It's not safe to use a gun. Maybe tennis balls, okay? Tapos may ano diyan, may butas, and then you will see diyan. They would hit the detector like that. Okay. All right. So keep that in mind. Okay. So if this were classical, so this is classical. And the particles are classical: tennis ball, marbles, stone, basketball, kahit ano. Okay. Basta kasya dito sa butas. You see that pattern. Now, what if you have, say, a pebble and then you drop that on a surface of water? Okay, so let's say this is the surface of water. So water surface. And then you have, say, a pebble. Okay, you drop that down. What would you see? You would see a wave, right? So if you look at, say, for example, top view, right? So let's say this is top view. Let's say nandito yung pebble, okay? It drops to the surface of water. You would see a wave emanating from where you drop the pebble, right? You would see a wave. Okay? That's a wave. That's different from a particle. Yung wave na yan, okay? It is extended and it goes through oscillatory motion. Okay, so it's a wave. Now, suppose you place a barrier. So again, let's say for example, ito yung ano natin, a pebble, tapos meron ng wave, okay? Emanating from where we drop the pebble, okay? Yan yung wave, right? Now, let's say you place a barrier, just like yung experiment natin kanina with the particle gun. Now you place a barrier dito. Okay, let's say blocks of wood, tapos may butas in the middle. Okay. So what happens? You have this wave, okay, when it encounters this barrier, what would happen after? Okay? After this barrier? What you would see is, and you can do this at home, you would see another wave dito emanating from that hole. Okay? It looks like that. Tawag dito diffraction. So merong diffraction because of this barrier. You get another wave, okay, that emanates from that hole in the barrier. Okay? Right? Do you agree? Okay. Questions? Let's see. So let's see. Questions first. Waves travel through denser materials. Yes, it depends on the frequency. Okay, so yung wave, we have a formula mamaya. Okay, wavelength. So a wave has a wavelength and then merong frequency. Okay. That frequency or the wavelength depends on the density of the material. Okay? If the material is very dense, actually, if the material is very dense, the wave can pass through better. Okay. Again, it depends on the frequency. The energy of the wave and the frequency are proportional. Okay, so the higher the frequency, the higher is the energy of the wave. So kapag mataas yung energy ng wave, mataas yung frequency niya, it can pass through. Okay? Pero kapag mababa yung frequency, then mababa yung energy, it might be stopped. Okay? Like for example, itong barrier, okay, that we have. Let's assume that this barrier is enough for the wave to stop. Okay? Ibig sabihin, the density of this barrier is enough to stop the wave. Okay? And then so yung wave then can just pass through the hole between the two barriers. Okay. The point here is that we would like to experiment with the wave itself, okay? Not passing through the barrier, but passing through this hole. Okay? So pwede kang just put in something that would stop the wave. Okay? Concrete, okay? Maybe wood is not enough. Then if it put concrete in or something denser. Okay. Now, just like yung experiment natin kanina, okay, with this particle gun, may dalawang butas, right? Let's put two holes as well. Okay. So two slit barrier again. Okay, but this time with wave. Two slit barrier. So again, this is our pebble, tapos merong wave emanating from the pebble, okay? All right. And then meron ka ng barrier. So now let's put in 2 slits or 2 holes, okay, in the barrier like that. Okay. Then what happens? Okay, so yung wave niyan hanggang doon yan. Okay, so it keeps on going. What happens? Because there are now 2 holes, then you get just like in this example where there is this hole and then merong diffraction pattern. Merong diffraction of the wave like that. Meron din dito, but now we have 2 of this. So that means there is going to be diffraction dyan. Okay, like that, okay, from the hole on top. And then there's another one here, okay. All right. What happens then? What you see is that the wave, okay, by the way, so when I draw a wave like this, may mga bilag-bilag, the lines means maxima, okay? So, you know, a wave, if you look at the side view ng wave, it looks like that, right? So this is side view wave, okay? So one line dito is yung maxima doon, okay? Yung maxima, okay? Yung maxima, okay? So that is the maximum of the line. So for example, dito na, okay, pagdating dito sa diffraction pattern, you have one wave, okay, itong from the top, okay, maxima na ganyan. And then another wave dito, there are 2 waves now involved. Merong maxima din, okay, but then they interact. Like for example, at this point, they would interact, okay. What happens to the waves, yung dalawang waves, when they interact? Okay? What happens is they would interfere. Merong interference when we have waves. This you can experience this, for example, in say yung mga earphones. Di ba merong earphones na noise cancelling? Okay, noise cancelling. Noise cancelling earphones. Okay. What it does is let's draw. So let's say usually in ear merong in ear na earphones. Okay, let's say it looks like that. Okay, so let's say this is the ear side. Okay, this is the outside. Okay. Right. It's noise cancelling. Ibig sabihin nun, let's say merong music dito from the outside. That means it's a wave from the outside. When these earphones detects that wave, what it does is it propagates another wave, okay, which exactly interferes, exactly cancels that wave from the outside, so that dito, pagpasok dun sa tenga, there is no wave. So it cancels, okay, the wave from the outside. So it's possible to have this electronics in these earphones where you have some sound wave from the outside, tapos yung earphones would generate exactly the same wave, pero exactly opposite pala, exactly opposite to the wave from the outside that would cancel and end up with no wave into your ear. So noise cancelling. Like if you have that noise cancelling earphones, that's what happens. That's why you don't hear anything dito. Right? Parang ano, right? Minsan it's not pleasant. Right? At some point, it is not going to be pleasant because you're not hearing anything from the outside. Now, how does that happen? The interference na yan. Okay, so many questions. Let's see. Yeah, interference. Yes, exactly. Yeah, you get 2 waves cancels. Right. Yes. Okay. So yeah. So tama yung mga sinasabi niya. Okay. So constructive and destructive interference. Yung mga hindi pa alam what's that. Okay, let me describe what that is. Okay, so let's say for example you have 2 waves. Okay, so let's say this is 1 wave. Okay, all right. So this is 1 wave, and then let's say there is another wave like that. Okay, kasi dito, right, there are 2 waves that are interfering now. They would meet at some point. Okay, so let's say this wave is moving that way, and then this wave is moving that way. All right, we get constructive interference. Constructive interference if you have, so yung wave, okay, let's say ito yung wave na ano, let's put them on top of each other, yung dalawang wave. So let's say this is one of the waves, okay, it's moving say to the right, and then this is another wave, yan yung wave that is moving to the left, okay, Let's put them on top of each other, and what do we see? Yung maximum nito, and then yung maximum nito, minimum, minimum, okay? They coincide, okay? When they coincide, what happens? They would add up. What you get is your outcome is going to be a large wave. This is constructive interference. Parang na-amplify, okay? Because they are actually the same. Okay, that is how we amplify sound waves, for example. Okay, just add the same sound, you get a louder sound. Okay, constructive interference. But we can also have destructive interference. Destructive interference is when baliktad yung yung nangyayari. So let's say this is one of the waves, okay? And then let's say this is the other wave. What happens? Okay, itong maximum dito, one of the waves, but this is minimum dito. Nag-minimum dito, nag-maximum dyan, nag-maximum dyan, nag-minimum, and so on. And what you end up with, when you add them up, okay, when you add them, itong maximum, okay, think of this, let's say, as say +1, okay, maximum, okay? And think of this, let's say, -1. So when you add them up, you get a 0. 0 yon. The same thing dito, okay? Ibig sabihin nun, the whole wave and this, the whole part of this part and then this part, they would all cancel and you end up with no wave. Nag-cancel yung dalawang waves. Right? We get that with waves. Okay, not with particles, but with waves. Let's see, my question. Yeah, overlapping is coincide. That's the same. Okay. So coincide or overlap. So when they overlap exactly, okay, so that means maximum to maximum, minimum to minimum, then you get constructive interference. So pag destructive, wala. Okay, walang I mean, nawala yung wave. Okay, when they cancel each other, then nawala. Parang yung sa noise cancelling earphones, yun yung nangyari dyan. Okay, you have sound waves that going in, but then the earphones would generate a sound wave that's exactly opposite to the sound waves that going in. That's how it cancels the noise from the outside. Okay, so may noise cancelling. Well, of course, it's not perfect. Okay, sometimes you will still hear a little sound, right? Palabas doon, okay? Because it's not always perfect. Kailangan kasi itong earphones, it must react very fast. Right? Kasi you have a sound wave moving in. Right? How fast is a sound wave? It's about 345, right, meters per second. Yun yung speed ng sound wave. So yung earphones mo must react to that wave, that sound wave, fast to cancel yung incoming wave. Right? So sometimes it cannot do that. Lalo na kapag high frequency yung sound from the outside. Okay, high frequency, anong high frequency sound? Mga high pitch sound or high frequency sound. Okay, so what you usually hear kapag may noise cancelling, yung mga high pitch sound sometimes lumulusot. Okay, hindi makapag-react masyado yung noise cancelling earphones. All right, but let's get back to this. Okay, so what happens then? Because we have two waves and they meet, they would interfere. At some point, it's constructive interference, but at some point, it's destructive interference. Like for example, itong okay, so let me use red. Okay, at this point, okay, at that point, di ba sabi ko, yung mga maximum ng waves are the lines, right? So at this point, yung dalawang maximum they meet, then this is going to be constructive interference. Okay, but at other points, you're going to get destructive interference, right? So if we have both constructive and destructive interference, what happens then? Okay, so again, this is our pebble, and then ito pa rin yung wave coming from our pebble. Okay, and then so now we have our two slits. Right, and then so we have this diffraction pattern dito, and then we have another diffraction pattern dito. let's say you can detect the wave dito. So let's say you have a wave detector at that side. Okay. So what would we see dito? Okay. What we would see is, so ito ano, so extend this hanggang doon. Okay, extend this hanggang doon. Okay. What we would see is there's going to be a maximum dyan, right? And then merong maximum somewhere there. Okay, may mga maximum. May mga maximum. If you look at the side view, okay, so let me go right here. Yung side view, what would we see? We would see yan, okay? And then you would see parang ganyan, and so on. Okay? Because of the interference, you would see something like that. Right? Okay? Nasa surface lang to. Okay? So these are surface waves. Nasa surface ng water. So you would see something like that. Okay, so yung question from the chat, yung canceling feature matches the characteristic properties of the wave that is being constructed or destructed. Yes. Yeah. So yung canceling feature niyan is the interference. Okay. So that interference, either constructive or destructive interference, you can see that in the detector dito on this side. What you see is that. Okay. Compare that to, well, okay, not yet. Okay, so we're still not going to compare that because naka-surface waves pa lang tayo. Okay, you would like to compare that to the one with the particle gun. Okay, but that particle gun is in 3D, right? So now imagine you have three-dimensional waves. Okay, passing through a two-slit barrier. Three-dimensional waves, 3D waves, we can imagine something like that. Right? Ano bang 3D waves? Let's say for example, meron ka parang pebble ano, in the three-dimensional space na ngayon. Kanina, di ba, surface lang, two-dimensional. Now imagine this is a three-dimensional wave. So imagine a series of spheres, mga sphere, okay? Yun yung mga maximum and minimum, maximum, minimum. So three-dimensional wave, okay? Three-dimensional wave, tapos meron kang two-slit barrier, okay? So then you get a three-dimensional wave, three-dimensional interference pattern. What would you see dito sa detector? Let's put this in side view. What would you see dito sa detector? Along the slit, okay? They have two slits. If this were particles, you would see a maximum dito, right? Meron dyan, okay? And then meron dyan. And then ganyan lang, right? If this were particles, yung particle gun. But no, okay? So let's erase that. This is not what ups. Ito may eraser. Ito, eraser. Okay. Eraser. Right? What do we see? What we see is parang yung kanina. Okay, so just compare this, extend this to 3D. This is a 2D. Okay, surface. Extend that to 3D. What we get is merong dark line dito. Oops. Okay. Iba yung ano niya. We get to see a dark line dito in the middle. And then lines. Doon yung constructive interference, and then may destructive interference in between. Okay, that's what we see. Okay, so imagine you have a three-dimensional wave now passing through this double slit barrier. You see, pag nagkaroon ng interference, parang ganun pa rin, okay, just like in the surface wave. Okay, parang ganun pa rin, but now extend that to a surface kasi naka 3D yung waves. Ito surface kasi ito one-dimensional, dot kasi naka two-dimensional yung wave. Pag naka three-dimensional yung wave, naka two-dimensional na ngayon yung interference pattern. It becomes that. Okay? All right? Can you imagine that? Okay? So yan, okay? Yan yung interference pattern if you have a wave. Okay? So now, let's go back to modern physics. What do we have then? Okay, we have, if we have particles, what you see is yung pattern ganyan lang, dalawang lines, okay? Yan yung pattern. But if we have waves, yung pattern is maraming lines, okay, merong malaking line sa gitna, and then some smaller lines away from the center. What do we see? So if you perform an experiment, okay, a double slit experiment, with electrons, okay, how can you do this? You know, yung mga lumang TV, yung may cathode ray tube, okay? Actually, ito yung mga TV, kasi let's say, ito yung mga TV na ganyan, okay? Yung mga malalaking TV, right? Parang ganyan, right? Actually, sa loob niyan, if you open, may ano yan dyan, may electron gun. Okay, merong electron gun dyan sa loob that shoots electrons. Okay, and then itong screen, yung screen which is some fluorescent screen. When electron hits that fluorescent screen, it will light up. That's how we see images dun sa lumang TV. Okay, it's actually electrons hitting the fluorescent screen to see the image. That's why it was not safe to watch TV. Okay, very close. Okay, pag dito ka malapit na malapit, yung mga bata, for example, like they watch TV really close to the screen. That's because electron gun yan. Okay, it's shooting electrons. Yung ibang electrons yan might actually escape. Okay, it might not hit the screen. So tatama yan dun sa sa mata and everywhere. Okay, that might cause some defects. Okay, sa cells ng whoever's watching very close. Okay. Right, but let's go back to this experiment. So you can get an electron gun, okay, inside the TV. Okay, so let's draw that gun. Let's say, for example, something like that. Okay, so let's say this is our electron gun. Okay, likod ng TV. Okay, so it's shooting electrons. Okay, and then you put a barrier, two-slit barrier. Okay, just like experiment kanina. And then you put the screen dito. Okay, some fluorescent screen. Okay, to see the image. Okay, kung ano bang makikita mo diyan? Are you going to see this or are we going to see this? Okay, moment of truth. Okay, ano bang nature ng ng electrons? Okay, electrons yan, right? We can imagine electrons to be dots, but then they pass through this double slit. What do we see dito? It turns out what we see is this. This is what we see. Bakit ganun? Electrons yan, right? Electrons, they are particles. They're supposed to be particles. This is an electron gun. Pagpasa doon, okay? Dapat dalawang lines lang doon, right? But no, what we see is an interference pattern like that. Bakit ganun? Because, as it turns out, electrons have a wave-like nature. Yeah, electrons have a property that is both particle. So particle wave property. Ano ibig sabihin yan? In this experiment, we see that parang wave yung electron, okay? Kasi wave lang yung gumagawa niyan, right? It's a wave. So parang wave yung electron. But then, the electron is also particle. Bakit ganun? What do I mean by that? Okay, electron is also particle. Let's say, for example, you place a camera dito. And then you focus on this. Okay, so let me put red. Okay. And then let's say yung camera naka-focus dito. Okay? Then that means you get to see the electrons one by one passing through. Okay? Di wala na ngayon na hindi na makatakas yung electron. You're seeing the electron itself passing through, let's say. Okay? One by one. Mag-wave pa rin ba yan dito? You will see that diffraction pattern dito, interference pattern. As it turns out, once you place this camera dito, and so you're observing the electrons passing through this double slit, what you see dito is not that, but yung property ng particles. Something weird, right? Something that you don't really see in classical, in ordinary everyday objects. Kapag naglagay ka ng camera dito, you're watching the electrons passing through one by one. Yung pattern dito is dalawang lines lang. Particles. But if you remove this camera, yung pattern makikita mo dito, interference pattern. Weird, right? It's not common sense, but that's what's happening. So what happens is, itong electron, as it turns out, has both particle and wave properties. It depends on how you observe it. If you observe it by making a measurement, making an experiment where you measure the wave-like property, walang camera, then you get a wave. But pag nilagyan mo yung camera, you're measuring the particle property, you get a particle pattern. Okay? Merong just one last equation, okay? I promise to end before 12. So, merong de Broglie wavelength. Sabi ni de Broglie, yung mga matter, yung matter, electrons for example, or you and I, okay, we're all matter. Meron tayong wavelength, corresponding wavelength, which is h over p. What is h over p? H is Planck's constant. Okay, this is 6.6 times 10 to the minus 34 joule second. And then p is the momentum. Okay, dito na naman ulit yung momentum. Momentum, which is mass times velocity. Tinanggal na natin yung vector notation, okay, because this is in 1D. Okay, 1D lang yun, one dimension. So they're all just pointing in the same direction, just mass times velocity. And then ito yung wavelength. Ano yung wavelength? Yun yung sa wave. Okay, if you have a wave, okay, let's say you have a wave like that. Okay, yung wavelength is the distance from, say, dalawang maximum. That is one wavelength. So yung wavelength, okay, if you have a particle with momentum yan, okay, meron siyang corresponding wavelength which is lambda. You can use that wavelength to analyze this problem and you get the correct interference pattern dito. Kapag walang camera. Okay? For example, some example. Let's say we have a car. Okay? Anong wavelength ng car? Let's say car is 1,000 kilograms. Okay? Then let's say moving with 100 meters per second. Okay? Mabilis, right? 100 meters per second speed. Okay? Yung lambda niyan, okay? Just put in h tsaka p, okay? Put in all the numbers. You're going to get 6.6 times 10 to the minus 39 meters. Okay? 10 to the minus 39. Masyadong maliit. Okay? So you have a car. Okay? Meron siyang quantum property, but yung wavelength niyan is too small. Okay? It is 10 to the minus 39. Almost negligible. Okay? Then you can just forget about its quantum property. Okay? Masyadong maliit. You can also put in yourself, for example, anong wavelength mo? Put in your mass, okay? Okay, and then let's say you are moving with some velocity, okay? Walking, let's say 1 meter per second, okay? And you put in your h, okay? You're going to get something that's very small as well. So meron kang wave-like property, but don't worry, okay? Kasi you will not face through a wall, or you will not face through your chair, okay? Di ba yung waves, right? Pwedeng destructive interference, constructive interference. Ibig sabihin, you can pass through objects because you're a wave. But as it turns out, yung wavelength mo is going to be very small. So very small wavelength, you can forget about your wave-like property. Okay? It's basically a particle. Pag maliit masyado yung wavelength. All right, I have more to say, but I don't have time. So let me end there, okay, and entertain questions. Okay, so I hope at this point, so one of the basic foundations of modern physics is that particles have wave-like properties. Okay, duality between the particle and waves. Dito. Right? So let's see, may questions? Sa camera, we are using flash, right? Light, yeah. Yes, okay, so okay, that's interesting question, yung light, no? So light, you know, light is a wave, right? It has okay. I was thinking about adding that, okay, but I might not have time. Okay. So light from the sun, for example, yung kanina, kasi yung sun, di ba? And then yung Earth dito, okay? So what you're actually going to receive is sunlight. Sunlight is a wave, okay? But then I said may photons. So as it turns out, yung light, which is a wave, also has particle properties. Duality pa rin. Okay? If you look closely, with the light, okay, it's actually containing photons, particles. how do you visualize this? You can visualize this as, say, for example, sa beach, yung sand, okay? Right? Yung sand, maraming sand, okay? If you look closely, then you can see each speck of sand. But then if you look far away, you can see like a homogeneous material, okay? Like a wave. So, parang ganun, okay? In this sunlight. So sunlight, if you look away, it looks like a wave. But if you look closely, it's actually made up of photons. Okay? So ganun din parang electrons, okay, or protons, or you and me. Okay? We are particles, but we also have wave-like properties. What type of camera do you use to observe electrons passing through the slits? Okay. So yung camera dito is just this is just hypothetical. Okay, yung camera that I see here. Can you see electrons? Yes, you can see electrons. Not exactly one electron. Okay. But what you can do is you can put a detector dito. Okay. You can put a detector dito. Okay. As long as you observe. Okay. Pag naglagay ka dito ng something that observes things that are passing through. Okay. You don't have to see the individual electrons. Okay. You just put a camera where it's observing what is going on dito. Okay. That would end up making the pattern dito particle-like. Okay. But to answer your question, can you see electrons? Yes. You can use lasers. Okay. Yung mga, remember yung Nobel Prize this year? They have this really fast lasers. Those lasers can see electrons. Okay. Because electrons can move. Typically, they have speeds of in the femtometer per second. Okay. And those lasers are in the femto, in that same range. Okay. So, but then there's something called the uncertainty principle. Okay, which I was hoping that I can discuss, but I don't have time for that.
Titingnan ka na kadala. Tawin mo. Doon na lang sa akin.
Yeah. Right. So let me just mention, uncertainty principle is delta x tapos delta px. It's bar over 2. Ibig sabihin nun, you cannot exactly pinpoint. Okay, merong uncertainty between yung location tsaka yung momentum. Okay, maybe another lecture, okay, for uncertainty principle, okay, if you are interested. Another question. Let's see. So next question done is there any massless particle? Yes, massless particles. Yung photons are massless. Okay, they're pure energy, yung mga photons. That's why, sunlight, kapag may mass yung photons, ibig sabihin nun yung sunlight will have mass. Then mararamdaman mo yan, right? Kung may mass yung photons, baka right? You would be squashed by the billions and billions of photons hitting you every second. Okay? Kung may mass yung mga photons. But luckily, the photons are massless. Okay, they carry energy, but they don't have mass. They're purely energy. Particles are purely energy, yung mga photons. Okay, another particle that is massless, well, not, I would say neutrino, but now we found out that yung mga neutrino have mass. Yung mga inside the proton, yung mga quarks. Okay? So inside the proton, if there's a proton, may mga quarks dun sa loob. Okay? There are 3 quarks inside. And they interact, okay, via sending this particle. Tawag doon na gluon. Okay? Yung gluon na yan are massless. Okay? They are also like photons. They don't have mass. Okay. At next question, okay, running out of time, I would like to clarify yung electrons ba yung particle wave or baliktad. Yung electrons merong property. Yung property niya is that it can be either a particle or a wave. It's the property, okay, yung particle wave. Property yan ng electron. Actually, not just electrons, but all matter, including you and me. Lahat ng matter merong particle wave property. Except that yung wavelength natin masyadong maliit. So we can just ignore that and then just consider ourselves particles. Okay? Sabi dito, itong de Broglie wavelength. I am wondering baka yung mga nakalagay na detect electrons are the ones interfering with the results. If I understand your question, yung mga electrons dito sa detector are the ones interfering with the results. No, okay? Kasi if you can calculate, okay, yung interference between electrons na galing dito, okay, and then yung electrons na nandito, okay? You can calculate that. As it turns out, that would give you a different pattern dito. And what we see is not that. What we see is the pattern that is from the interference of dalawang electron waves from the two slits. Okay? Right? Yeah, merong effect yan, okay, but the effect is not what we see. Okay? It's really the mas malaki yung interference between the two electron waves dito, okay, passing through this double slit. Okay?
Sir Ed?
Right, wala nang questions. I hope,
Sir Ed?
yeah.
May question po tayo from a participant on YouTube. Ang sabi niya, in the electron diffraction experiment, whether an electron is a wave or a particle, does it depend on the observer? Sir?
Okay. Can you repeat what you say?
Ayan, sir. Ang question po from YouTube is, in the electron diffraction experiment, whether an electron is a wave or a particle, does it depend on the observer?
Yes, exactly. Yeah. Yun ang ano. Okay, so one of the things that is not what we have in classical physics, yung observer, may role yung observer in what we get. Okay? Like for example dito, kapag may so this camera is like our observer. Right? Itong camera na to. Okay? Itong camera dito ba? It's like the observer. When the observer looks at what happens in the double slit, you get particles. But when the observer does not look, then you get waves. That reminds me, yung Schrödinger's cat. It's the same phenomena. Okay, Schrödinger's cat. Okay. You can look it up. Okay, Schrödinger's cat. You have a cat inside the box. Okay, meron kang cat dun inside the box. Right? But then itong box na to, merong something that kills the cat. Okay, let's say for example, radioactive material. But then you don't know exactly when that radioactive material would kill the cat. So if you don't look, what happens to the cat? It's either alive or dead. Okay, parang we don't know exactly. But if you look, then yun, okay, whether you know whether the cat is alive. So ganun din yan dito. May role yung observer. The observer changes the outcome of the experiment, which is not intuitive, right, compared to classical. Okay, the classical, walang role yung observer. Well, yung role maybe is well, okay, modern pa rin yan. Kasi yeah, walang ganung klaseng role yung observer sa classical. Other questions? Wala nang
May questions pa po? May questions pa po ba tayo before we end? Sir, meron po yata ditong isang question from the chat. Yung itatanong ko rin po sana about connection ng wave-particle duality sa uncertainty principle.
Aha. Yeah. Right. Yeah, so since you asked, okay, so let me then continue with this. Okay. It will just take 5 minutes. Okay. So yung uncertainty principle, is delta x, delta px, okay, greater than equal to h bar over 2. Ano yung h bar? H bar is just h over 2. Okay? Some number. Yung h is yung Planck's constant. Yung ito kanina. Ito, saan yan? Ito, okay, so 6.6 times 10 to the minus 34. Okay. 2 pi, okay, divide by 2 pi. Okay. That is h bar. What is this and what is that? Okay. itong delta x is, suppose you would like to measure position. Okay, let's say for example you have an object, it's a basketball, okay, that was on the floor. You want to measure position, then the position is going to be x plus minus delta x, right? Meron kang error bar. Saan galing yung error bar? Because your ruler, for example, hanggang centimeter lang, okay, pag you-measure, you don't know exactly nasaan yung pinaka-baba ng bola, okay? So meron kang parang error bar, okay? That is delta x. You can also measure momentum. Then meron siyang p plus minus delta p. Okay, where p is mass times velocity. Okay? So maybe you measure velocity, and then yung velocity merong error bar, and then multiply by the mass, that becomes the delta p. So anong sinasabi dito? Yung delta x times delta px should be greater than equal to x bar over 2. Ibig sabihin yan, yung error bars yan, okay? This concerns only the error bars, not the measurement itself, but the error bars. Suppose we know exactly where the, say itong basketball, suppose we know exactly, so we know exactly x, yung basketball, yung location. That means delta x is 0. Okay? We know exactly ano yung x, nasaan yung basketball. If delta x is 0, then yung delta x, delta px, right? Greater than equal to x bar over 2. Okay? Lipat mo yung delta px, delta x dun sa kabilang side. Merong x bar over 2. And then merong 1 over delta x. Okay? Right? Lipat mo tong delta x dito sa kabilang side. Then, if delta x is 0, this goes to infinity. That 1 over 0 is infinite. Nag-infinite. Ibig sabihin nun, yung error bar dun sa momentum goes to infinity. Ibig sabihin nun, we don't know exactly anong velocity ng bola. Bakit ganun? We know exactly anong yung bola, right? But now we don't know anong velocity niya. Infinite yung error bar. Okay? So we don't know exactly yung velocity niya. That is a wave. Okay? Because a wave, that, okay? Itong wave na let's say you know, baliktad tong wave, right? You know the velocity, but then you don't know exactly nasaan yung wave. Nasaan yung particle dyan. Okay? So let's say, yan, okay? Let's say you can say delta B 0. Then what is delta x? Delta x becomes infinity. Okay, from this. Okay, baliktaran na yung role ng delta B at delta x. So in the wave dito, nasaan yung particle? Error bar is infinite. Okay, it's just somewhere there. Okay? But we don't know where exactly the particle. Okay, does that answer your question? All right. Other question? May questions sa chat?
May last may last question na lang po, sir, siguro yung.
Sige.
And that's where it all becomes relative. So ito po yung last question natin.
Relative as in relativity.
Siguro po, sir.
Okay. Okay, I would say iba yung relative sa relativity, that's also observer dependent. Okay. So in relativity, reality depends actually on the observer. If the observer is moving, okay, iba yung reality niya with the observer that's at rest. Okay, that's a different lecture. Okay, but that relativity, okay, is different from dito. Okay, where delta x and delta px get h bar over 2. This just says that yung the limits of what we can know. Okay? So what we can know is hindi pwedeng 0 yung delta x kasi mag-infinite yung delta px, or the other way around, ganun din. Okay? So it's a balance between error bars in x and error bar in delta px. Always greater than. Okay? So ito pa, masama pa kasi greater than. It's not less than but greater than. So ibig sabihin nun, mas malaki parati to kaysa itong h bar over 2. Okay? All right. Yeah. So I am going over time. Yeah.
Okay po, sir. I think this is all the time that we
All
have.
right. Okay.
Maraming salamat po for the lecture and for answering the questions from our audience.
Thank you too for letting me share my excitement in this topic. Yeah.
I'm sure madami pa po silang tanong, sir, pero wala na tayong time.
Yeah.
And we also would like to thank Ma'am Rose for her introduction to the BSMST program kanina. And we just like to remind our audience to please fill out the evaluation form to get your certificates. We're going to post the link in our chat box. Tapos i-flash din po natin sa screen. Ma'am Ana, pwede po ba nating i-flash ngayon yung ating QR code para makita ng audience? Huwag niyo pong kalimutan para makuha ninyo yung certificate. Ayan, may game pa sana tayo, kaya lang we ran out of time. Pero ito po. Yan, yun pong evaluation form. Please don't forget to go to the link and fill out the evaluation so that you can get your certificates. Tapos maraming salamat po sa lahat ng dumalo to our 2 Saturday event. And bago po tayo magpaalam, let's please turn on our cameras for a photo. So Sir Arvin, pa-photo na lang po. Sige, stop sharing po muna tayo. Ayan.
Okay, so in my screen, there are 3 pages. Okay, so please remain smiling as I take screenshot of every page. Okay. Okay, so page 1. Then page 2. And last page. Okay.
Okay na po.
Okay na po.
Okay, maraming salamat
Thank you so
po.
much po.
Thank you, sir. Maraming
Thank you
salamat
so much po.
po.
Maraming salamat po. Thank you so much, sir.
Thank you po.